Hello everybody. You might be wondering why I'm starting out on Unit 3, Lesson 3, and the reason is because in Unit 1 we pretty much covered a ton of stuff. So we covered actually pretty much everything in Unit 3 with the exception of one thing, which is long division and synthetic division. Alright, so we're going to be talking about that today. Alright, we're going to learn how to solve polynomial equations and how to divide them and stuff like that. So first thing we're going to do is we're going to try dividing using long division. Alright, so let's do a quick little review of what long division is. Alright, so if we do long division, so let's say we say, I don't know, 4 into 103. Alright, so we're going to talk about what different things are, just a quick little review, like what is that number called, what is this number called. Alright, so 4 is your divisor, so that right there, that's called your divisor. Alright, this right here, this guy is called your dividend. Dividend. Alright, make a better E. There we go, dividend. And the answer is going to be called the quotient. So first thing you're going to do is you ask yourself, how many times does 4 go into 1? Well, none. But 4 goes into 10 a total of 2 times. Hopefully you remember this from elementary school. Alright, you get an 8. Then you have to do what? You have to subtract it. 10 minus 8 is 2. And then what do you do with the old 3? You drop it down, right? And then 4 goes into 23 a total of 5 times. 5 times 4 is 20. You subtract, you're left with a 3. And what do we call that 3? We call it the remainder, right? Hopefully this is bringing up fond memories when elementary school. All right. And when used to, I remember my elementary school teacher said, just put R and put a 3. That's a horrible R, but you know what? We'll just deal with it. Now, how could we write it as a mixed numeral? Well, that would be 25, and what's our remainder? 3 out of our divisor, which is a 4, and that's what we would write. Now, all of this together is considered to be what's called the quotient. All right. So this process of long divisions can be the same process that we use on problem number 1. All right, so I'm going to go ahead and zoom in a bit, okay? There we go, problem number 1. So what does this say? This says 2x to the power of 4 plus 14x cubed minus 2x squared minus 14x. And what I'm going to do is I'm going to divide into that polynomial. And I'm going to divide it by this binomial x plus 7. Okay? Whew. Now how do we do that? So we're going to do, hopefully by me doing this, it'll make sense. Alright, so right now, I'm going to put a little line right here. And I want you to understand what we have to do is we have to take away, what we're going to try to take away is our product. Whatever we multiply up here, we're going to multiply to the x and to the 7, but we're trying to get this 2x to the power of 4. We're trying to get it to 0. That's what we're trying to get. We're trying to get that to 0. So what am I going to do here? So here's what I'm going to do. I'll put a little empty box here. Put a little empty box. We're going to ask ourselves, what number times x is 2x to the power of 4? I'll say it again. What number times x equals 2x to the power of 4? Well, that number has to be a 2x cubed, because 2x cubed times x, if I take this and I multiply it to the x, I get 2x to the power of 4. But I also have to take that 2x cubed and I got to multiply it to the 7. And 2x cubed times 7 is a total of 14x cubed. Alright, cool. What we're going to do is we're going to close off the parentheses. And what I have to do is I got to take away the first one and I got to take away the second one. Well, what is 14x cubed minus 14x cubed? Sweet, I get another what? I get another 0. Alright, so now, what do I got to do now? Just move this down. I'm going to move this down. So I'm going to move it down here so we can see it a little bit easier. I got negative 2x squared minus 14x. I'm going to change colors here. All right, I'm going to put another box right here. What I'm trying to figure out is what number times x what number times x is negative 2x squared? Okay, so I got to make a negative 2x squared so that when I subtract all of this, it equals 0. That's what I'm trying to do. What number? Well, we're going to have a minus. We're going to have a 2. All right? All right, so we got negative 2 times x is negative 2x, but it looks like I'm going to have to add another x right there, because negative 2x times x is negative 2x squared. That works. Now we're going to do negative 2x times 7, and negative 2x times 7 is negative 14x. Ooh, it looks like, once again, negative 14x minus a negative 14x. Those turn into a positive, okay? Because a negative times negative is a positive, and that cancels out once again. Wow, looks like we're done. So our final answer, our quotient is 2x cubed minus 2x. Okay? Now, if you wanted to ever check your answer, you could actually check your answer in Desmo. So hold on one second. All right, so what I've done is I've typed in our original polynomial, all right, right here into Desmo. So there's our graph right there. Now, if I take my original divisor, which was x plus 7, and I multiply it to our final answer, which was our quotient, which was 2x cubed minus 2x. 2x cubed minus 2x. It's kind of cool. Check this out. You guys see how these are the exact same? So that kind of lets me know that I did it correctly. So it's a way of checking myself. All right. So when I divided this polynomial by x plus 7, I got the binomial of 2x cubed minus 2x, and it matches. So that's kind of how you can do it. All right. So that's long division, which kind of takes a long time. So what we're going to do is we're going to show you a better way. We're going to use what's called synthetic division. All right. So we're going to use synthetic division. All right. So what I'm going to do is I'm going to do this exact same problem, except I'm going to use synthetic division, and we're going to get the same answer, just in a different way. Now, usually, when you look at a textbook, synthetic division, you'll see a little symbol that looks like this. They call that the chair, all right? And then what I'm going to do is I'm going to label this x to the power of 4, x to the power of 3, x to the power of 2, x to the power of 1, and x to the power of 0, which is your constant. And then we ask ourselves, this is how you're going to set it up, okay? So right now, you made a little chair, all right? And if you're dividing it by this binomial, which is x plus 7, you always got to figure out what number makes it equal to 0. Well, that is negative 7. So you got to use a negative 7 here. Okay, so that's the number one thing. That's like super important. If you don't do this, you will get the answer wrong. So if you see x plus 7, you got to figure out what number would you have to plug in to make it equal to 0. And you put that number right there. Okay. So how many x to the power of 4s do you have? You have a total of 2. How many x cubes do you have? 14. How many x squareds do you have? Negative 2. How many x to the first do you have? Negative 14. And then there are 0 constants at the end. Now, if you were to see in a textbook, what you would see is you'd see like a line drawn right about there, just kind of like so. All right? Now, it's going to be very, very, very important that the first step that you always do is whatever number that is, I'll try to do a better job drawing down. Whatever that number is, you bring it all the way down. Okay? Now, this number right here, anytime you multiply it down to this bottom area, so you are always going to multiply. Okay? You're always going to multiply that, and whatever that number is, you're always going to multiply it to all these numbers down here. And up here, you're always going to add the products. So I'm going to put plus, because you're always going to add. All right? So here we go. See if you can follow this pattern. Negative 7 times 2 is negative 14. And negative 14 plus positive 14 is 0. Negative 7 times 0 is 0. And negative 2 plus 0 is negative 2. And negative 7 times negative 2 is positive 14. And that's 0. And negative 7 times 0 is 0. And we get 0. So you get this answer, 2, 0, negative 2, 0, 0. How am I supposed to interpret it? Well, it's going to be pretty easy. So check this out. Whatever number you started with, if it's x to the power of 4, this is always going to be depressed by 1. So this will always be x cubed, or 1 less than whatever that power is, always going to be 1 less. So if that was a 5, this would be a 4. If that was a 7, this would be a 6. If that was a 10, that would be a 9. But right now it's a 4, so it's a 3. Then this one is just in descending order. It's really easy. It's x squared, x to the first, x to the 0, and right here, this is called a remainder. Now, when you have a remainder of 0, that lets you know that this guy lets you know it is a factor of this polynomial. So anytime you get a remainder of 0, that lets you know that whatever you divided into it was a linear factor. All right, it's pretty cool. Now, let me show you. It's kind of cool on Desmos. What does a linear factor do? Watch this. If I put x plus 7, look what happens. That's one of the linear factors right there. Right there at -7. What's this? -1. Watch. If I put x plus 1, guess what? That's another linear factor. What's this number? 0? Okay, fine. X right there. 0. And then what's another one? 1. I could put x minus 1. So there's all the linear factors. What are the linear factors? That, and that. Notice that, which where it perfectly hits where the y value is 0. So all of these would be factors, okay, of this polynomial, except we have a 2 in there. All right, so watch this. Let's see if we can rewrite it. Ready? Let's go 2, parentheses, x plus 7, parentheses, open parentheses. Let's just throw in an x just for fun. All right, let's go and throw in an x plus 1. And then let's throw in an x minus 1. Sweet. And let's change colors to orange. Yes, change it to orange. Okay, now check this out. Hit done. Whew. Okay, I know there's a whole bunch of stuff going up on the screen. So we found one of the linear factors to be x minus 1. Take it away. We found one of them to be x. Take it away. Found one of them to be x plus 1. Take it away. And our original factor that we found was x plus 7. Take it away. I want you to understand these are all the same polynomial. This is in its complete factored form. Usually you put an x right next to that too, so I'll make it a little bit nicer, okay? I'll go and put the x like right here. But I want you to understand, these all mean the same thing. Kind of cool, huh? And what are all these called? These are all called linear factors of the polynomial. All right, let's go back to our problem. How do I interpret this? Well, how do you interpret it? Well, how many x cubes do you have? You have 2x cubed. How many x to the x squared do you have? None, so I don't worry about it. How many x to the first do you have? Minus 2x. And then everything else is not there, so that's your final answer. Using synthetic division. Wait a second. That was my final answer using long division. You're right. This is your final answer using synthetic division. Now, there is a rule for the only time you can ever use synthetic division, and it has to be a linear factor. Okay, you can't use it if it was something being squared. So if that was said x squared plus 7, I would not be able to use synthetic division. I'd have to use long division. Okay, so what we're going to do is we're going to do another problem. We're going to do number 3 right here. Okay, do problem number 3. Now, I'm going to set it up the way I like to set it up, which is not what you would see in a textbook, but you can do it either way. I don't care as long as you do it correctly. I like setting it up this way because for me it's faster when I'm doing it by hand. So the first thing I always do is I put the number that's supposed to be right over here. All right, so instead of drawing this, I just draw this. Now, what number plus 3 equals 0? Well, that number is -3. So I'm going to right here, over here, I'm going to put a -3. Then I'm going to start labeling some things. So here we go. I always label y cubed, all right? Y squared, y to the first, y to the power of 0, all right? So how many y cubes do I have? I have a total of 1. How many y squareds? 1. How many y to the first? Nothing. How many constants at the end? I got -10. So here's a very important. If you don't see anything, you got to put a placeholder of 0 if you don't see any of that particular exponent. All right, so there's 0 y to the power of 1s. All right. Now, how do I do it? Drop this down. Put a 1 there. -3 times 1 is -3. Add them together, I get -2. -3 times -2 is 6. What do I do here? add them together, get a 6. Negative 3 times 6 is negative 18. Add them together, negative 28. That's not good. That means it's not a factor. Look at that's my remainder. And how do we go? We always go by descending. So if that's y cubed, I know this is going to be y squared. Then I have y to the power of 1. I got y to the 0. So how do I write my final answer if it says 1, negative 2, 6, negative 28? What would be my final quotient? Check this out. I got 1y squared minus 2y's plus 6. Now how do I add my remainder? I put minus and I put 28 over my original divisor, which is y plus 3. That's how you write your answer. Just like that. Okay? So, like, if you think about, remember how we talked about long division to begin with? Like, it was 25 and 3 over 4 because the remainder was 3 and the divisor was 4. You do the same process right over here. Our divisor was y plus 3. So that's why I put y plus 3 right there. If that doesn't make sense, it's okay. We're going to do one more. We're going to do another one. Okay? Whew, this is a long one. It's a long one. All right. There we go. Okay, here we go. If that says n plus 2, I'm going to make this a negative 2. That's important. So remember, it's always what number makes that equal to 0. Then I go n to the power of 4, n to the power of 3, n squared, n to the power of 1, and n to the power of 0. And then you ask yourself, how many n to the power of 4s are there? 1. How many n cubes are there? Negative 1. Even you can't see it, it says negative 1 right there. Okay? How many n squareds? Negative 10. How many n to the power of 1s? A total of 4. And how many constants at the end? 24. So guess what? This one's a little bit different. We don't have to fill in a 0 spot because everything has a number. And then all I do is I drop it down. Just like this. So bring it down to 1. Negative 2 times 1 is negative 2. What do we do with these? We add them together. Negative 1, negative 2 is negative 3. Negative 2 times negative 3 is positive 6. What do we got to do? Add them together. Negative 2 times negative 4 is positive 8. What do we do? Add them. Just add them together. And negative 2 times 12 is negative 24. Add them together. Sweetness. This is a factor because my remainder is 0. That's awesome. So if we have a remainder of 0, we know this is a linear factor of this. Okay? So how do I write my final answers? Here's my final answer. If that's n to the power of 4, that's n cubed. This is n squared. This is n to the first. This is n to the 0. So here's my final answer. I got 1n cubed minus 3n squareds minus 4n plus 12. And you got a remainder of 0, so you're done. And that is your final answer. Now, if you wanted to check this in Desmos, you could type all of this in. You just got to change all the n's to x's. So you write, and wherever there's an n, you change it to an x, and then you would multiply this times this, and these two multiplied together will equal that big old long polynomial. All right, so that's synthetic division. Hopefully that helps you in your future endeavors with synthetic division. Just remember, if this was a 2, I would not, if it was being squared, I could not do synthetic division. I'd have to go back to doing long division, which is doing this method right here. Okay, y'all have a good day.